In this example, I'm working a problem from MyMathLab on graphing polynomials. I need to answer parts A through E for the function shown below, so my function f of x equals x cubed plus 4x squared minus x minus 4. Part A says use the leading coefficient test to determine the graph's end behavior. Which statement describes the behavior of the ends of f of x? As the polynomial is given in standard form, it's very easy to find the degree of the polynomial. What's the highest exponent on any of the x's? It's this term here, it's a 3. So the degree of this polynomial is odd. That means the ends of the graph are going to point in opposite directions. One will fall, the other will rise. And the leading coefficient helps you determine which one rises and which one falls. What is the number that we're too efficient to write in front of this x cubed term? There's a positive 1, so our leading coefficient is a positive number, and that means when we graph this, our graph is going to fall to the left and it will rise to the right. So let's see which one looks like that. So C says the graph falls to the left and rises to the right. So I'm going to pick that and then hit enter, and I got that one right. Next part, we have to find the intercepts and decide whether they cross or touch the x-axis. So I'm going to need to go to my scratch paper. So I'm going to put the video on pause for a second. So here's my function, and I need to find the x-intercepts. Remember, to find the x-intercepts of a graph, it's the same as saying find the zeros of the function. So the first thing I'm going to want to do is I'm going to want to try and factor my function if at all possible. So f of x equals x cubed plus 4x squared minus x minus 4. How many terms do I have? 4 terms. There's a possibility it might factor by grouping. If it works, it's very quick. So let's check this one to see if it will factor by grouping. What do the first 2 terms have in common? I can factor out an x squared, and it's going to leave me with x plus 4. Bring down the middle sign, so I have minus. And what do the last 2 have in common? Well, not much. The only thing I can factor out of those is a negative 1. And if I factor a negative 1 out of a negative x, I get positive x. Factor a negative 1 out of a negative 4, I get positive 4. Did factor by grouping work? Is this binomial the same as this one? Yes. So this is one of the cases where it works. So my common binomial factor is x plus 4. I factored that in front, and what does it leave behind? X squared minus 1. So now, can I factor x squared minus 1? Yes, it's the difference of 2 squares. So I'm going to get my 2 binomials. The square root of x squared is x. I'm going to need opposite signs between them, and the square root of 1 is 1. So now I have f of x written in factored form. Now to find the zeros or x-intercepts, you set f of x equal to 0. So you get 0 equals x plus 4 times x plus 1 times x minus 1. 3 things multiplied together equals 0. Using the zero product property, you set each of them equal to 0. So I have x plus 4 equals 0. Subtract 4 from both sides, you get x equals negative 4. X plus 1 equals 0. Subtract 1 from both sides, x equals negative 1. And x minus 1 equals 0. Add 1 to both sides, x equals positive 1. In this problem in MyMathLab, they do not want the x-intercepts as ordered pairs. All they want is a list of the x values of the x-intercepts. So for this problem, I'd write -4, -1, -1. But don't forget, if you ever need to write an x-intercept as an ordered pair, the y-coordinate is always 0. The last thing I have to decide is the behavior at these intercepts, and that depends on the multiplicity of the zeros. If I look at my factored form, how many times do each of these factors appear in the factored form? Just one time. So each of them has a multiplicity of 1, which means the graph will cross the x-axis at each of these x-intercepts. So now let's go back to my MyMathLab. So now I'm ready to put in my x-intercepts. I need to type an integer or decimal and use a comma to separate the answers. So I'm going to put in -4, -1, +1. Check the answer. Got that part right. Now, at which x-intercepts does the graph cross the x-axis? Well, it crossed at all of the x-intercepts, so I just put in -4, -1, -1, and hit enter. And that was correct. And at which x-intercepts does the graph touch the x-axis and turn around? None. Next, we need to find the y-intercept. That means set x equal to 0. So I'm going to put a 0 here, 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 and here. So all these three terms are going to go to 0. The only thing left is going to be -4. So my y-intercept is -4. Next, we need to determine whether the graph has y-axis symmetry, origin symmetry, or neither. So let's go to my scratch paper where I've written a few notes. The graphs of even functions are symmetric with respect to the y-axis, and even functions are functions where f of -x equals f of x. The graphs of odd functions are symmetric with respect to the origin, and those are functions where f of -x equals -f of x. But because we're dealing with a polynomial function, we don't have to work all this out. There's a shortcut for polynomial functions that says if all powers of x are even numbers, then the function is an even function. If all powers of x are odd numbers, then the function is odd. However, if there are both odd and even powers present in a polynomial, then the function is neither odd nor even. And don't forget, all constant terms are considered even. Well, looking at our function up here, I have odd exponents on x's and I have even exponents on x's. So this function is neither odd nor even, so it will not be symmetric with respect to the y-axis or the origin. So let's go back to MyMathLab. So now we know that this has neither symmetry. So now we're ready to draw the graph. We click to enlarge the graph. This is the tool I'm going to use, the 4-point cubic tool. So click on that, and I need to graph 4 points on the graph. Well, luckily, I found 3 x-intercepts and 1 y-intercept. So I'm going to start graphing from the left. The very first x-intercept coming in from the left was -4. That's my first x-intercept. The next one was -1. Then I had my y-intercept, which was -4. And finally, my last x-intercept of 1. So there is my graph plotted with 4 points. So we save it and then check our answer.